Section 3, we will learn how to factor trinomials of the form ax squared plus bx plus c by grouping. A method that can be used to factor trinomials of the form ax squared plus bx plus c, where a, or the leading coefficient of x squared, is not equal to 1, even after we take out the greatest common factor. And we call this the grouping method. In some places, maybe college algebra, you will see it referred to as the AC method. And this method of factoring uses the factoring by grouping that was taught in Module 6, Section 1. Just to quickly review factoring by grouping, if we have 4 terms, we would group the first 2 terms and the last 2 terms. Notice that although 1 is the GCF for all 4 terms, the first 2 terms have a GCF of y. So the first group has a greatest common factor of y, and the second group has a greatest common factor of 2. So we would factor a y from the first group, and in doing so, we would be left with x plus 1. We would factor a 2 from the second group, and when we do that, the second group is left with an x plus 1. At this point, each term has an x plus 1 in common, so we write that one time, and the resulting polynomial. Here are the steps that we will use for factoring trinomials by grouping. Step 1 is to factor out a greatest common factor, if there is a greatest common factor other than 1. Trinomial, find 2 numbers whose product is a times c and whose sum is b. So we're always going to start by multiplying this first and last number together. Once we factor out the greatest common factor, we will want factors of that product whose sum is the middle number. Step 3, we will write the middle term using the factors we find in step 2. In step 4, we will factor by grouping. Let's try our first example, 8x squared minus 14x plus 5. Step 1, we try to find a GCF. And we find the GCF here is 1, so we can't factor anything from the original polynomial. Step 2, when we multiply a and c, it gives us 8 times 5, which is 40. At this point, we want 2 numbers that will multiply to 40, but that will add to the middle term, negative 14. Remember, the only way 2 factors that multiply to a positive number can add to a negative number is if each factor is negative. And so as we go through the process, and I won't write every factor in the list of factors for 40. I hope that by now you are able to do that, or that you can find the factors quickly enough on your own. But as we go through the list of factors for 40, we find that 4 times 10, and remember each of these must be negative, negative 4 times negative 10 equals positive 40, and negative 4 plus negative 10 equals negative 14. So these are the 2 numbers that satisfy both conditions. Now previously, when we didn't have a number in front of x squared, we would be finished. But because we have an 8 in front of x squared, we can't automatically plug these 2 numbers into the 2 sets of parentheses and be finished with the problem. Here's what we do. We take those 2 numbers that we just found, and we're going to put them in place of our original middle term. So 8x squared stays the same. Now in place of minus 14x, we're going to use minus 4x and minus 10x, because it essentially means the same thing. Now that we have 4 terms, we can go through the process of factoring by grouping. Remember, factor by grouping, we create 2 groups, one with the first 2 terms, one with the last 2 terms. And in this process, we will find 3 greatest common factors. We start by finding the greatest common factor of the first group, the blue underline, which would be 4x. When we factor out 4x, the resulting polynomial of that group will be 2x minus 1. plus, we always put a plus sign between our groups regardless of the next sign, whether it's positive or negative. When we look at the next group, the two terms underlined in red, they have a common factor of 5, and anytime this leading number, here the negative 10, anytime the leading number in a group is negative, let's take a negative out as well. So we factor a negative 5, and the resulting polynomial will be a positive 2x minus 1. So we know we're on the right track when these two sets of parentheses, these two binomials match. And the binomial will actually be our third greatest common factor. So we factor out the 2x minus 1. When we do so, we write the resulting polynomial. We have a 4x left as our first term, a minus 5 as our second term. Now, I won't do this for every problem, but let's go through and check and make sure this actually works. So we rewrite our answer, or our proposed answer. We FOIL, so we draw our FOIL arrows. 2x times 4x is 8x squared. 2x times negative 5 is negative 10x. Negative 1 times 4x is minus 4x. Negative 1 times negative 5 is a positive 5. We combine like terms, and we find that we have 8x squared minus 14x plus 5, exactly where we started. So we know the two factors we found are correct. Let's try another example, 6x squared minus 2x minus 20. We go through the same process. First, we try to factor a GCF. And in this particular example, the GCF is 2. So we factor a 2 from each term, and we're left with 3x squared minus x minus 10. Once we factor the GCF, we then look at the number in front of x squared, or the variable squared, the number at the end, and we multiply those two numbers together. 3 times negative 10 is negative 30. So we want two numbers that will multiply to give us negative 30, but that will add to give us negative 1, the number in front of our middle term. Again, remember, if two numbers multiply to make a negative product, one number must be positive, one number must be negative. If the sum is a negative number, then the number furthest away from 0 must be negative. So let's keep that in mind as you find the factors of negative 30. Just to save time and space, we know that 5 times 6 is 30. 6 is furthest from 0, so we get the negative sign. And 5 plus negative 6 is negative 1. Again, we can't skip straight to the answer, but now we have the two terms that we are going to use in the next step. So we rewrite the problem. We bring down our greatest common factors just to tag along at this point. We rewrite the middle term, negative x, as 5x minus 6x. So we're left with 3x squared plus 5x minus 6x minus 10. And now with the terms inside parentheses, we're going to factor by grouping. We group the first two terms. We then group the last two terms. And we are starting the process of finding three greatest common factors that will lead to the answer. Now, at this point, we have a greatest common factor on the outside. It's nothing but a tag along. We can't lose it. We don't want to drop it off. It will look somewhat confusing with the number of parentheses and brackets we have, but it's better to write the greatest common factor every time than it is to lose the greatest common factor and hope that you write it at the end. So as we look at the first group, we notice that 3x squared and 5x have no numerical factor in common. They do have an x in common, though, so we factor out an x, and those two are left with 3x plus 5. In the next group, remember we said that if the leading term is negative, we're always going to take a negative out. So plus negative, 6x and 10 have a 2 in common. We factor out a negative 2, and that leaves us with a positive 3x and a positive 5. Our two binomials match, and that's a good thing. If they didn't match, we would have a problem. So the binomials actually end up being the next greatest common factor. So out of everything inside square brackets, we factor out a 3x plus 5. In the first term, when we take away the 3x plus 5, we're left with an x. In the second term, we are left with a minus 2. And at this point, we're finished. Remember, if you want to check your answer and the result has a greatest common factor out front, distribute that into the first set of parentheses and then FOIL. Let's try the problem 30a squared minus 22a minus 28. We go through the same process we had before. We factor out the GCF. And when we do, we find that the GCF is 2, so we factor out a 2 from each term. That gives us 15a squared minus 11a minus 14. In the next step, we will multiply the number in front of our squared term and the constant at the end. So we have 15 times negative 14, and that gives us negative 210. So at this point, we want two numbers that will multiply to negative 210, but that will add to this middle term. We'll add to negative 11. Again, the only way we can get a negative product is if one of our factors is positive and one of our factors is negative. So we need one positive number, one negative number. We see that the sum is negative, so the number furthest from 0 must be negative. Remember the steps you would go through for finding the factors of 210. And when we do that, we see that we could find 10 times 21. 21 is furthest from 0, so we get the negative sign. 10 plus negative 21 is negative 11. These are the two factors we will use in the next step. Do not put these into sets of parentheses and call the problem finished yet. So in the next step, we rewrite our middle term, negative 11a, as 10a minus 21a. Everything else will stay the same. So we have 2 times 15a squared plus 10a minus 21a minus 14. Now that we have 4 terms inside the parentheses, we can factor by grouping. So we group the first 2 terms, we group the last 2 terms. And our 2, which is our greatest common factor at this point, is just a tag along. So in the first group, the 2 terms underlined in blue, they have a 5a in common. We factor out 5a and we are left with 3a plus 2. The next 2 terms, remember, if this first term in a group is a negative, we factor out a negative as well. So plus, negative, they have a 7 in common. Factor out negative 7. We're left with 3a plus 2. And we know we're on the right track because our binomials match. So in the answer, we have our greatest common factor. We then factor out the binomial, 3a plus 2. When we factor out the 3a plus 2 from the first term, we're left with a 5a. From the second term, we're left with a minus 7. And just like any other factoring problem, you can always go back and check your work. When you multiply it back, you should end up with the original polynomial. Let's try one last example, 3z squared plus 5z plus 6. We go through the same steps we have before. We try to find a GCF. We find that the only greatest common factor is 1. So we won't factor anything from the polynomial. Step 2, we multiply the coefficient of the squared term and the constant. 3 times 6 is 18. Now we want numbers that multiply to 18, but that add to 5. Because our product and our sum are positive, we will use two positive numbers. So we try 1 and 18, that adds up to 19, that's not good. 2 and 9, that adds up to 7, that's not what we want. 3 and 6, that adds up to, I'm sorry, I said 2 and 9 is 7, that's actually 11, but either way, not going to work. 3 and 6 is 9, that's not good either. And we have run out of factors. 18 has no more integer factors. Once we exhaust all the possible factors, that means this is not factorable. We would say this polynomial is prime.